Okay. So I just worked out for a little bit. It was still a workout. I'm going to have to express these points fluently. So recognize popular cloud service providers is the next point. I could just say, Microsoft, Azure. Let's see, like Google Cloud Platforms. Could be wrong there. Oracle. And there's another one. I'm only familiar with really Azure and Google Cloud Platforms. Oh, Amazon Web Service, duh. Yep, I was right. Google Cloud Platform. IBM Cloud. There's Oracle. And Alibaba. And this is a bit more in depth here. Salesforce. Several cloud service providers have gained prominence due to their extensive service offerings, reliable performance, and substantial infrastructure. Here are some of the most popular ones. Amazon Web Service, a subsidiary of Amazon, is the largest cloud service provider in terms of market share. AWS offers more than 200 products and services including computer power, storage, network, database, analytics, machine learning, Internet of Things, security, and more. 2. Microsoft Azure. Azure is the second largest cloud service provider. It is particularly popular among enterprise due to seamless integration with other Microsoft products. Azure provides a vast array of solutions suitable for all types of industries. It supports several programming languages, tools, and frameworks, including both Microsoft-specific and third-party software and systems. 3. Google Cloud Platform. Google Cloud Platform is a suite of cloud computing services that runs on the same infrastructure that Google uses internally for its end-user products, such as Google Search and YouTube. It provides a range of services including computing, storage, data analytics, machine learning, and networking. 4. IBM Cloud. IBM Cloud offers a suite of cloud computing services for businesses of all sizes. The IBM Cloud is particularly popular among businesses that have high performance needs and requires strong support for integration with other IBM products. 5. Oracle Cloud. Oracle offers a comprehensive cloud computing service offering that includes IaaS, PaaS, and SaaS, and Data as a Service, DaaS. That's new. These services are used to build, deploy, and manage workloads in the cloud. Alibaba Cloud. Alibaba Cloud is the largest cloud service provider in China and is gaining recognition worldwide. It provides a comprehensive suite of cloud computing services, including those for compute, storage, data analytics, and machine learning. Salesforce. Salesforce is known for its software as a service offerings, particularly its customer relation management (CRM) service. They're they also provide a platform as a service solution known as Salesforce Platform. These providers continue to expand their services and tools, ensuring a wide range of options for businesses and organizations of all sizes across various industries. Each provider has its own strength and specialties, so it's the best choice depends on the specific needs of goals of each business. Okay, that's the gist of it. Those are the players, man. Evaluate common cloud service types, including compute, storage, network, and security services. Let's see here. Cloud services typically fall into several categories, including compute, storage, network, and security services. Here's an evaluation of these common service types. Computer service. Compute services include infrastructure services like virtual machines, containers, and serverless computing. 1. Virtual machines. Services like AWS, EC2, Azure Virtual Machines, or Google Compute Engines provide a resizable compute capacity in the cloud. These VMs eliminate the need to invest in hardware upfront, allowing applications to be developed and deployed faster. 2. Containers. Services like Google Kubernetes Engine, or GKE, Amazon's Elastic Kubernetes Service, EKS, and Azure Kubernetes Service, AKS, allows you to run and manage Docker containers at scale. Containers can provide a consistent and reproducible environment, which is great for deploying applications across different computing environments. 3. Serverless computing. Services like AWS, Lambda, Google Cloud Functions, and Azure Functions allow developers to run code without provisioning or managing servers. Serverless computing can automatically scale your applications in response to incoming traffic, and you only pay for the compute time that you consume. Storage services. Cloud storage services offers a scalable and often more affordable alternative to purchasing, maintaining, and upgrading in-housing storage infrastructure. 1. Block storage. Services like Amazon Elastic's Block Store, EBS, Google Persistent Disk, and Azure Disk Storage provide a low-latency, high-performance storage for data that requires frequent read and write operations. 2. Object storage. Services like Amazon S3, Google Cloud Storage, and Azure Blob Storage are great for storing large amounts of unstructured data like images, videos, and backup files that doesn't need to be accessed frequently. 3. File storage. Services like Amazon Elastic File System, EFS, or Azure File Storage, and Google Cloud File Storage provide managed file storage that can be shared across multiple machines, instances, or containers. Network services. Cloud networking services focus on delivering network functionality and capabilities into a virtualized form. 1. Virtual network services like Amazon VPC, Azure Virtual Network, and Google VPC allow you to provision a logically isolated section of the cloud where you can launch resources in a virtual network that you define. 2. Load balancing. Services like AWS, Elastic Load Balancer, Azure Load Balancer, and Google Cloud Load Balancing distribute network traffic across many resources to ensure no single server bears too much demand. 3. Content Delivery Network, CDN. Services like Amazon CloudFront, Azure CDN, and Google CDN are global cloud networks of edge servers that cache static content closer to users, improving speed and reducing latency. Security services. Cloud security services provide a range of features to produce cloud-based infrastructure and data. Identity and access management, IAM services like AWS IAM, Azure Active Directory, and Google Cloud IAM allow you to control user access to resources. 2. Security management. Services like AWS Security Hub, Azure Security Center, and Google Security Command Center provide you with a comprehensive view of your high-priority security alerts and security posture across your cloud environment. 3. Data protection. Services like AWS Shield, Azure DDoS Protection, and Google Cloud Security Scanner provide additional layers of protection against DDoS attacks, malicious web attacks, and other threats. That's pretty cool. These are just some of the examples of the common types of cloud services. The specific names and functionalities can vary between providers, but the basic concepts remain the same. Each type of service offers different capabilities to help meet your specific needs. I feel like the super cyber bum, yo. This is awesome. We buy ugly computers. Analyze security concerns specific to each cloud service model. Cloud security is a critical concern in each of these three primary service models. Infrastructure, IaaS, Platform as a Service, PaaS, and Software as a Service, SaaS. While some of the security concerns overlap, there are also specific issues that are more relevant to each model. I think I've already touched base on this one. Analyze security concerns specific to each cloud service model. Yeah, I don't need to do that anymore. Anticipate common cloud issues. Here we go. Despite these many benefits of cloud computing, there are potential issues that businesses need to be aware of. 1. Data privacy and security. With data being stored remotely, there can be concerns about the security of the data, especially sensitive and confidential information. Ensuring that the data is securely encrypted both at rest and in transit is essential. 2. Compliance. Various industries have specific regulations for data handling and storage. Compliance with these regulations can be complex in a cloud environment, especially when data is stored in different regions or countries. 3. Vendor lock-in. The difficulty of moving data and services from one cloud provider to another is known as vendor lock-in. It can be challenging and expensive to migrate from one cloud platform to another due to compatibility issues and operational changes. 4. Downtime and availability. While major cloud providers are typically reliable, outages can occur, leading to service interruption. It's important for businesses to consider the redundancy and backup plans in case of such outages. 5. Data governance. While data being stored in the cloud, controlling who has access to the data and how the data is used and managed can be challenging. 6. Cost management. While cloud services can offer cost savings, it can also be easy to overuse resources in the cloud, leading to unexpected high costs. Effective cost management and monitoring are critical in the cloud environment. 7. Skill gap. The skills needed to manage cloud resources can be different from those needed to manage on-premise resources. There can be a steep learning curve involved in moving the cloud, and there is a high demand for professionals with cloud skills. 8. Latency. Depending on the physical location of the cloud servers, some users may experience latency, especially in the case of applications where real-time interaction is required. 9. Data loss and recovery. In the event of a data breach or loss, the recovery process can be complicated. This makes having a data backup and recovery strategy very important. Proper planning and management can help mitigate these potential issues, making the cloud a powerful tool for businesses of all sizes. See how this technical jargon is what I am trying to comprehend, grasp, and express myself. I can understand it pretty well. I'm getting better at reading it, but it's still difficult for me to carry a conversation using this type of terminology. And that's the reason why I'm reading all this stuff out loud, y'all, because it helps. Explain the troubleshooting steps. Also, the book probably has different answers compared to OpenAI. I'm just doing this as a way to expand my vocabulary. And also, I hate to say it, but if you don't really know too much about what you're talking about, OpenAI will give you the terminology and the concepts needed to at least sort of be able to carry on the conversation and keep up, as opposed to just sitting there I don't know what I'm talking about, but when these buzzwords pop up, it's okay, I think I get it a bit now. Troubleshooting in a cloud environment can be a complex process due to the distributed nature of the infrastructure and a variety of technologies involved. However, there are general steps that can be taken when addressing problems. Here are the basic steps for troubleshooting. 1. Identify the issue. The first step in troubleshooting is identifying the problem. This can be done through user reports, error messages, or monitoring systems that alert you to issues. The clearer the understanding of the problem, what is happening, and who /what is affected, the better. Gather information. Once you have identified there is a problem, the next step is to gather as much information as possible. This could be error logs, system reports, user experiences, or anything else that provides insight into the problem. 3. Replicate the issues. If possible, replicate the problem. The steps can be crucial in understanding what's going wrong. It confirms that the issue exists. However, this may not be possible or practical in all situations, especially in a production environment. 4. Analyze the information. Use the information gathered from a hypothesis about the sources of the problem. Look for patterns and correlations and try to isolate the variables contributing to the issue. 5. Develop the test potential solutions. Once you have a hypothesis, come up with potential solutions and test them in controlled environments. It is important to not only change one variable at a time, to know exactly what is solving the issue. 6. Implement the solution. After a solution has been tested, it can be implemented. Monitor the solution closely to ensure it has resolved the issue without causing new problems. 7. Document the issue and resolution. Finally, make sure to document the issue and the steps taken to resolve it. This can help in solving similar issues in the future and aids in building knowledge base for troubleshooting. So hit the forums, y'all. Remember that this process may be iterative. You might not find the right solution on the first try, so you may need to repeat some of these steps until the problem is resolved. Iterative, that's a word I am very familiar with. Also, troubleshooting steps can vary greatly depending on the specific technology or service in question. Cloud service providers often have extensive documentation and support resources to assist with troubleshooting their specific services. What is it called when you read ahead? It's like you try to guess the word next so you can read faster. I do that a lot. And I end up saying the wrong word as a result. And really, this doesn't really go into depth on how to troubleshoot a cloud computing problem. It's really, this methodology is used for just about any troubleshooting problem you might face. Either with software or just in the real world in general, just basic steps. Identify the issue, gather information, replicate the issue, analyze the information, develop and test potential solutions, implement the solutions. Document the issue and resolve. You can basically use that methodology in just about anything, really, As it says earlier, the troubleshooting environment can be a complex process, Identify helpful preventive measures. Preventive. I guess that works too. Okay. Preventive measures can go a long way in ensuring smooth operation of your cloud environment and reducing the likelihood of issues. Here are several measures that can help. 1. Monitoring. Implement monitoring tools to keep an eye on your cloud resources. Regular monitoring can help detect issues easily, often before they impact users or services. 2. Regular updates. Regularly update your systems to ensure you have the latest security patches and bug fixes. This is crucial for protecting your systems against known vulnerabilities. 3. Backup and recovery plan. Regularly back up your data and ensure that you have a recovery plan in place. This can help protect against data loss and make recovery faster and more efficient in case of a problem. 4. Security measures. Implement robust security measures, including firewalls, intrusion detection systems, encryption, and regular security audits. Also use identity and access management tools to strictly control who has access to your resources. 5. Perform testing. Regularly test the performance of your applications and services to ensure they are operating correctly and efficiently. This can help detect any potential issues that may affect the performance or functionality of your service. 6. Training. Ensure that your team has the necessary training to manage and troubleshoot your cloud environment. The more familiar they are with your specific setup, the more likely they are to prevent issues or resolve them quickly. 7. Redundancy. Design your system for redundancy. This can help prevent downtime or data loss in case of a failure. Many cloud providers offer tools and services to easily replicate your resources and data access across multiple regions. 8. Data management. Implement a robust change management process. This can help ensure that changes to your environment are properly tested and reviewed before being implemented, reducing the likelihood of issues caused by changes. 9. Documentation. Keep thorough documentation of your systems, configurations, and any past issues or incidences. This can help in troubleshooting future issues and can be a valuable resource for training new team members. Remember, prevention is always better than cure, and these measures can go a long way in preventing issues or minimizing their impact when they do occur again. Okay. Let's see. I already added like 2,000 more words or so. This is it. And that only took about 26 minutes. All right. So